All right, number 10, determine if x minus 3 is a factor. So if x minus 3 is a factor, it's also a 0. So x is 3. If, when we do synthetic division, it's the 3 that we're going to put out there. Your coefficients are 1, -1, -2. You need a placeholder because I'm not mentioning any x's, and minus 36. Don't be the kid who can't figure out synthetic division. I've seen that kid every year I've taught, and they fail. That's just what it is. They fail. They complain that it's too hard. It's not too hard. It's you. Figure it out. We're going to drop the 1 because remember our acronym was DMA. And if you don't know synthetic division and you're afraid to ask me, ask somebody else. 3 times 1 is 3, or maybe go to YouTube and type in synthetic division. -1 plus 3 is 2. 3 times 2 is 6. -2 plus 6 is 4. 3 times 4 is 12. 0 plus 12 is 12. 3 times 12 is 36. And -36 plus 36 is 0, which is my remainder. So yes, x minus 3 is a factor because the remainder is a 0. If it was not a 0, it would not have been a factor. All right, arithmetic sequence has a third term of 4, so I'm just going to put some blanks out here. Put the third term is 4. Don't know the fourth term, don't know the fifth term. I know the sixth term is 13. Now, what I'm going to have to do is I'm going to have to add once, twice, thrice. My job here is to figure out what I add to 4 3 times to equal 13. And it turns out it's a 3. It goes 7, 10. I'm plussing 3. Now, what you can kind of do, and I don't do this because the numbers are pretty easy to me, but you can take 13 minus 4, and once you figure out that you've got to add 3 times, divide it all by 3, and you get 9 over 3, which is 3. That's your ratio. That's what you add. That's your ratio. That's your difference, your common difference. And that's what you add. Now, I want to know the first term, what goes here, right? What's that guy? So I'm going to take away 3. I'm going to take away again. First term is -2. Not a hard problem. Not. Will it be missed? Yeah. An arithmetic sequence is as follows: -5, 11, 27. Write a rule using a sub n is the first term plus n minus 1 times the common difference. Now, the first term is -5. The difference here, it looks to me like it's plus 16. That's your difference. Now, we're going to clean this up. The goal is to look like mx plus b. We want to make it look like a line because they are lines. We're going to distribute that 16, 16n minus 16, and then -5 plus that. It's pretty bad when the technology can't keep up with me. Now, 16n is going to be out front. -16 plus -5 is -21. Easy peasy lemon squeezy. All right. 13 is a simplification problem. They're not too hard, I don't think, but we'll find out, right? Let's just look at these things piece by piece. You got the cubic root of 27, you got the cubic root of x to the 7th, and you got the cubic root of y to the 6th. Now, the cubic root of 27 is 3, because 3 times 3 times 3 is 27. The cubic root of x to the 7th, I don't know how you need to think about this, but you might think of it like this: x cubed, x. 3 plus 3 plus 1 is 7. Each of these cubic roots of x cubed is an x. So I have an x, and then I have this cubic root of x left over. So that's x squared cubic roots of x. Y to the 6th would be the cubic root of y cubed times the cubic root of y cubed. And each of those creates a y, and y times y is y squared. So I have a 3, I have a y squared and an x squared, and inside that radical, there is still a cubic root of x. This is a very low-level simplification problem. All right, 14, convert the decade decay model. The amount after time passes is 35 times 97/100ths the t over 10 into a yearly decay model. Now, you're able to do that by simply moving pieces of exponents inside and out. When I see t over 10, what I actually see is 1/10 of t. So I'm going to move that 1/10 inside, and I'm going to leave that t on the outside. all I have to do, and then I have to push buttons. So first I convert into a yearly decay model, and then I find the yearly decay rate of decay. So I'm going to go to my trusty TI-84, and I'm going to see what the 10th root of 97/100ths is. That is the 10th root, by the way. You might read it as the 10th power, 1/10th power, but it is the 10th root. 0.9970. 0.9970 if you know how to round. And now it's a yearly model because it accepts time in years, okay? Now your decay rate, this lines up with the P times 1 minus R to the T. See how these two pieces line up? So all I got to do is take this away from 1. R is 1 minus 0.9970, which is pretty small, 0.0030, which is going to be 0.3% per year. Sorry, I should say 0.30% per year, because those are rounded numbers. Ta-da! You know, if you can't do this, you know, push buttons in a calculator or something, kids. All right, 15. Literally the easiest problem on the whole quiz will be missed so bad. Oh, it'll be so bad. This is function notation. This says x equals 3 is a 0. See where it says that? This one says x equals -2 is a 5. Now, factors come from zeros. So if it ain't equal to 0, I'm not even going to pay attention to it. Now that says x equals 3 is a 0. That means that x minus 3, what happens when you shift left, is a factor. So we're taking the x value and we're changing the sign to become a factor. This one would be x minus 4. Change the number, change the sign. This one would be x plus 4. And this one, you could write it as x plus 0, but you're just going to say x. So 1, 2, 3, 4 factors, because there were 4 things that equal to 0. All right, I'm going to pause, be right back. Need a small mental break. Not really, just taking a break. Ooh, a logarithm, number 16. Solve this bad boy by hand. What you're going to do is you're going to isolate the log and then exponentiate. All right, so let's do the easy stuff first. We're going to subtract 2. 4 logs, whose base are 2, and argument is x minus 3, is equal to 16. Now we're going to divide out the 4. A single log of base 2, whose argument is x minus 3, is equal to 4. And now we're going to go through the process of exponentiating. Base argument exponent. 2 gets raised to the 4th power, and g equals x minus 3. Now 2 to the 4th, last I checked, was 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 equals x minus 3, and then just add 3 and you're done. 19 is x. Easy peasy lemon squeezy. Moving forward in my life, solve using tech. Now you're going to have to show me how you write these in a TI-84. You got to show me. You're going to do this using change of base form. A logarithm base b argument a can be pushed buttons by doing log of a over log of b, or ln of a over ln of b. And I'm going to do ln's because I'm an ln kind of guy. So I've got a 4. This has to be converted. I'm going to do natural log 3x minus 4 over natural log of 2, and then plus 5. That's what I'm going to put in y1. In y2, I'm going to have ln of 2x plus 1 sitting pretty over the natural log of 7. That's what I'm going to be pushing buttons on. So I'm at y equals, clear out what I got there. Let's see, I got a 4. Then I'm going to go to math, num, n over d. Numerator over denominator if you're a little dense. And it put the 4 up top, which is fine. It can be there. We had a 2x, oh, we have a 3x minus 4. Not looking at the right spot here. And she is sitting pretty over the natural log of 2. And again, if you're a log person, do be log. It's cool. And then we had 5. The right-hand side, natural log of 2x plus 1. And that's sitting pretty over natural log of 7. As small as this one is, I would just do this. Natural log 2x plus 1. Because it saves me time of finding that fraction key. It's really up to you. You do you. And now I'm going to do a zoom 6 because that's how I trained you all to do it. Oddly enough, not how I was trained, but we never actually played with the window a whole lot. And this is what I see. And solutions happen when things cross paths. That's where they happen. So second trace, 5 for intersect. Get close. And I noticed I had to press that button a few times. There's going to be lots of y'all who just copy somebody else's work or you share it with your friends and they're going to get the graph and then they're not going to know what to do. Stop sharing with your friends. Bad things happen. And then I'm going to look at my x value because that's all I cared about. 1.4918. What did I say? 4918? Yeah. And moving forward with my life, I think this is the last grouping here besides some bonuses. Use the graph for 18 through 22. Find the real zeros and their multiplicity. Now, zeros are also known as x-intercepts. That's what they are. Let's make some notes here. Zeros are x-intercepts. Touches happen at least twice. Crosses happen once, at least once. But anyways, so let's talk about my zeros here. I have an x equals, looks like -1. That is a touching. Notice it's bouncing off and coming up. So its multiplicity is 2. I have one here at 0. And you'll notice that it is touching and passing and going back up. It has a multiplicity of 2, which is what the other one had, 2. Sorry about that. And the last one I have is x equals 3. And you are literally crossing through the x-axis. So its multiplicity is at least 1. It's odd. Degree and sign of the polynomial based on n behavior. This bad boy is starting high and ending low. You know, that's kind of what I'm thinking. Starts high, ends low. That is a negative x to the odd. By the way, if you take these multiplicities, 2 plus 2 is 4, plus 1 is 5, you'll discover that 5 is odd. Least degree of the polynomial based on turning point theorem. Now there's 1 turning point, 2 turning point, 3 turning point, 4 turning point. There are 4 turning points. The degree here, x to the n, is turning points plus 1. So this is x to the 5th, which is, by the way, what those things add up to. 2 plus 2 plus 1 is 5. It's at least x to the 5th. The known factors, all right, we're going to take our zeros, we're going to make them factors. -1 is a 0, x plus 1 is a factor. This guy right here is just x, and this guy is x minus 3. Those are your 3 known factors. They come from your zeros. Your factored form, and you got to find a, and you also need to include your multiplicity. So we're going to start off with a times x plus 1, and this bad boy is squared, times x, which is squared, and then times x minus 3. That's my form that I plug into. Now, I need a point to plug in, and I got one right here at 218. Y is 18 when x is 2. And I've noticed that this is one of those things that just really messes with kids. I don't know why, but it does. 2 plus 1 is 3. 3 squared is 9. There's a 9 here. 2 squared is 4. 9 times 4 is 36. 2 times -3 is -1. -1 times 36 is -36. So 18 is equal to a times the -36. Then you do division, right? So a is -1/2. So my correct answer here would be y equals -1/2. I'm going to put the x squared first. X squared times x plus 1 squared times x minus 3. Really, I should have put the x minus 3 first, but whatever. And now the bonuses. Solve these two things by hand. I'm going to glance at these real quick. I'm going to pause. I'll be right back. All right, so I just want to see how rough they were, see if I need to do anything ahead of time or not. They're not too bad. This one is just a process of move the logs to one side and numbers to the other. You're going to have a log base 2 of 4x plus 3. Take away a log base 2 of 2x plus 8. This is the lesson that we did Monday. It is, we did this Monday. And it equals 5. Now, we condense the subtraction of two logarithms through division. If a logarithm is negative, its argument goes in the denominator. I don't know why I have that extra set of parentheses there. There we go. And that still equals 5. Now, base, argument, exponent. 2 to the 5th equals 4x plus 3 over 2x plus 8. You know, what's funny is like 6 years ago, this wouldn't have been a bonus question. Now it's a bonus question. It's a shame how far our race has fallen in just a few years. Makes me sad. 2 to the 5th is 32. And we're going to clear the fraction. I'll clear the fraction by multiplying both sides by 2x plus 8. Now, 2x times 32 is 64x. 8 times 32 is 256. Seems legit. X is on one side, numbers on the other, and this one's got a negative answer, which means it doesn't actually have an answer, I don't think. My guess is if I looked at a graph, they would not cross paths. Let's make sure I didn't do anything wrong. I don't feel that I did. So 64x minus 4x is 60x. And 3 minus 256 is negative 253. So that means that x is negative 253 over 60. Now, here's the thing about that. I'm quite confident, actually that may not be negative. That's not a very small negative number. Let's see here, we got negative 253 over 60. Yeah, that's going to be over 4. It ain't going to work. If I plug that in on the right-hand side, I'd be trying to take the logarithm of negative. I forgot a parentheses there, didn't I? And the logarithm's going to puke. And just to show you this thing doesn't have an answer, let's just go ahead and type it in TI-84. So this guy would be the natural log of 4x plus 3. It'll be sitting over the natural log of 2, or log if you like logs. And then minus 5. The right-hand side would be the natural log of 2x plus 8. Sitting over the natural log of 2. Zoom 6. So there's the left-hand side, here comes the right-hand side, and they don't cross paths. There's no solution. So there is an answer, but it's extraneous. And you would be expected to figure out the extraneous answer, because it does have one. All right, solve this bad boy by hand. Now this one is a little harder because you'll notice that these bases are different. So I'm going to do change of base on log base 16. I'm going to make it a log base 4. Why am I doing that? Because I have to. Both logarithms have to be the same base. That way you can condense or whatever. I'm going to use any of the properties, condensing or setting equal. I have to have the same base. Now, log base 4 of 16, or argument 16, is actually 2. Because what power of 4 creates a 16? It's a 2. So this becomes log base 4 of 2x, sitting pretty over a 2, and then add 1. All right, next move, double both sides. Or I could subtract 1, but I'm going to double both sides. So 2 log base 4s of 8x plus 2 is, think about the 2 here, goes there, cancels, goes here, plus 2, is a log base 4 of twice x plus 2. Exponent, log base 4 of 8x plus 2 quantity squared. I'm going to go ahead and move this guy over. Minus log base 4 of 2x is 2. Condense, we condense through division. A log base 4 of 8x plus 2 squared, sitting pretty over 2x, is 2. Exponentiating is up next. That's the fun part. That 4 is going to be raised to the second power. I guess I'm red now. 4 is raised, no, back to black. 4 is raised to the second power, and it equals this ugly thing. 8x plus 2 squared over 2x. I'll multiply both sides by 2x. Now 4 squared is 16. 16 times 2x is going to be 32x. And I'm going to go ahead and FOIL this out. 8x times 8x is 64x squared, plus 16x, plus another 16x, so plus 32x, and then plus 4. Now, cool. 32x's are in balance, throw them away. Subtract 4, divide by 64. Negative 1/16 is x squared, so x is plus or minus the imaginary root over 4. I'll let you figure out how I did that. Now, obviously, these are both non-real, but they are the solutions. And there's your bonuses. All right, there's your twin for Friday. Hope you enjoyed.